So we're going to be talking about Redux today. My name's Justin McMurdie. Last night we had a discussion, and a friend of mine told me that the goal of every presenter should be to break a rule that's so obviously a rule but not in the code of conduct, so they have to change the code of conduct next year. So I'd like to talk about the 2016 election. I'm just kidding. So there's my slide. Briefly, I graduated from BYU. I've worked at several different companies. I play way too many video games. That's me. But you didn't come here to learn about me. You came to talk about or learn about Redux. So I want to ask, who has used Redux before? Awesome. Most of you know more than me. No. What this talk is actually about, we're going to do a brief overview of Redux, some of the principles behind it, and some of the problems it solves. We'll have some examples. Some are contrived, some are real. And if we have time, there's a very small workshop that I started and never finished, but we'll use anyways. Now, what this talk is not, I'm not going to teach you everything you need to know about Redux. I'm not going to teach you the answer to life, the universe, and everything. Most of you know that anyways. And this talk is definitely not perfect. With all of that said, let's get started. So Redux is a predictable state container for JavaScript apps. Redux can really be boiled down to the three principles that the author used when creating it. Redux is inspired by a lot of great tools. One of them, libraries, even frameworks, Elm. Elm was inspired by Haskell. This is not a new pattern. You heard other people talk about this pattern today, even. It's nothing new. It's not going to blow you away unless you've never heard it. First time I heard the pattern, I thought, oh, that's amazing. And then it took me a while to understand how to use it. So the three principles of Redux. First is that Redux needs to have a single source of truth. It needs to be the single source of truth. It can be kind of helpful to think of it as a database that lives on the front end. The second principle is that your database or your state is read-only. So you're not going to be mutating the state directly. There is a way to change the state, and we'll talk about that in a moment. And then here's the third principle. Changes are made with pure functions. So these principles sound great. I think it's important to see how data flows through Redux and through an application that uses Redux. Keep in mind that Redux itself can be used with any library. Redux was actually my introduction to React. So in my mind, they're kind of tightly coupled. And so the workshop that I started creating and got partway through that we will use if we have time, I actually forced myself to use Angular 2 in Redux instead, just so that you can see how it can be implemented with any library. Redux is about these principles, the library, and there's similar libraries that emulate it. RxJS is one, or not sorry, NGRX Store, which uses RxJS to implement Redux. But here's the data flow for a Redux application. You have your store, your single source of truth. That's in the bottom on the middle. And if you're using like a React application, you're going to render with a pure function that takes data and renders a view. So you have your view that reads from the store. The only way you can change your store is with that pure action that we talked about, and that's going to be a dispatch. So your view dispatches actions. An action is what reducers read from. Or an action is sent to a reducer is probably a better way to say that. The reducer then takes the action and the current state and generates a new state. So it's non-destructive. You're not mutating the state itself. They should all be pure functions so that you can do some really cool things that you'll see today. So about the single source of truth. I couldn't think of a great way to show this besides showing code, so we're going to jump in between code and the slides for a little bit. So this is an example of a totally arbitrary thing I started working on. So you can see that was my single source of truth in the application. I have a state, which is my root level. My application has people, a people object, which contains entities and a selected ID. And so you can see that it's a very simple setup. Instead of using that one, I wanted to do something a little bit more complex. So I have a very poorly formatted application open here. So this is actually code that I didn't write. This is written by Dan Abramov, the creator of Redux. But I'd like to go through some of it so we can talk about the benefits of Redux, some of the things that it can help solve. Now I have my console open because in this we're using middleware to log the state to the console. There are dev tools that we'll see later, but I wanted to keep it really simple for this example. So this is a simple to-do application. You can mark things as done, as not done. You can add new to-dos. There's lots of things. I mean, it's pretty basic work. They're pretty basic. There are filters. So this would be an example to-do application. Now, you notice that every time I've been doing something, my console is filling up. And what's happening, this is you're seeing the implementation here of the flow. What's happening is every time I do something, I interact with the UI. The UI is firing an action, which goes to the reducer, which is generating a new state. And if we open up one of these, let's go to the latest one, for example, and that might be too small. Can everyone see that better now? So we have our previous state object. So this is our single source of truth that we started with before the action took place. So we have all the to-dos by ID, so all IDs, and a by ID array. So this way you can see which things are visible. It's a different structure than I probably would have started with, and you'll see something that I started with later. But this is a way that you can speed things up by you're storing them separately, then you're referencing them. So that was the state before I made an action, and the action I made itself. And the nice thing about Redux is everything is vanilla JS. An action is just a JavaScript object. So what's coming in is an object with a type of add to do, which my reducers are looking for. One of my reducers is looking for an ID and the text. So it takes that and generates a new state object. So now you can see that there are 3 items in my all IDs and 3 items in my by ID array. So this is kind of high level, you can see it working. That would be the single source of truth as an example. The next thing I'd like to show is about state as read-only. You've seen the application, so let's jump into the code and talk about that just a little bit. So actions in Redux, there's a typo there. It's supposed to be state.setToDo. You're not going to be controlling your state directly. It's controlled mostly by convention. So if you've used the object spread operator from ES 2017, I think is what it's in now, or ES Next, whatever. The object spread operator will let you take an object and break it down to its components inside of another object. So your reducer is creating a new object every time, not modifying the old one. You can enforce not mutating the state via middleware. There's quite a few options available, like you can use deep freeze and other things in your unit test to make sure you're not breaking at that. But we'll talk about that later. So let's look at the code for that, which is, there we go. So let's look at our reducer itself. This is our to-do.js reducer. So what happens, and that is probably too small again. A reducer is a pure function, so you can see that every case, it's returning a new object. Now, it's referencing the old state, but it's all, and then you have a default condition here. So when the case of the action object that is sent to the reducer is add to do, it's going to return a new ID, and the payload is in the action here, action.id, action.text, and then the completed state, which we're setting to false. We could, if we wanted to, instead send that in as part of our action object. So we'd have to add a UI element so that when they click add to do, they could say add to do as completed, add to do as false. In a to-do application, it's pretty safe to say that if you're adding a to-do, you haven't done it yet. Because if you'd done it, you wouldn't need to add a new to-do. And then there's another case here. So this reducer handles just my to-do objects. That's important because you can have many reducers in your application, and I would suggest that you do. Each reducer can have access to as much state or as little state as you define. In this case, when I'm referencing state inside this function, I'm not referencing the single state object, I'm referencing a chunk of the object. So a higher level, here's the to-dos part of the state. It has different actions. Some of the actions are the same even. So reducers can listen to the same action. They can cause different state changes. And then you can see that right up here at the very top, we're importing a helper method from Redux called combine reducers. So that you're going, if you nest your reducers deeply, which again I would recommend so that each reducer handles small portions of the state, you'll be using that a lot because you can combine and combine and combine, and your final combination will be your root reducer, which in this application takes place here. So you notice that the to-do reducer, or to-dos reducer, is using the to-do reducer, and then the index.js file here is only referencing to-dos because it's already been combined once. Does that make sense? Am I not if you can hear me? If it makes sense, cool. All right, shake your head this way if you have no idea what I'm talking about. Awesome. So the pure functions, you saw that. Here's an example here. You have your state, and this is the destructuring syntax that I was talking about. So your reducer is going to receive two items. It will receive the state and the action. It will use the action to generate action. It will use the action and the new state, or the old state, to generate a new state. So here I'm using ES6 or the spread operator to take my state and break it up, and then I'm using the action and breaking that up as well. If you've never used this the spread operator before on an object, it will change your life. It's amazing. It's just a nice syntax that makes things a lot easier. So let's go back to, let's see, we talked about pure functions. Okay, then let's take a look. How much time do I have? Still, he's not listening, so I'm good. All right, so this is an example application. It's a little rough. I was going to make it a lot more extensive, and there's still some things that are in progress. So on the left side, I want to show some of the dev tools that Redux enables. And this is actually written in Angular 2 and NGRX Store, which technically is not Redux. I am aware of that. The API is the exact same. It's heavily inspired by Redux. It was written to be used in Angular 2 using observables. And so instead of a plain old JavaScript object as your store, your source of truth, it's an observable that is your source of truth. And that has some advantages and disadvantages. But for our case, we're going to treat them the same. I want to show some of the dev tools, and I wanted to force myself to decouple it from React, because you can use this with Vue.js or Aurelia or Angular 2. So I thought this was an important demonstration. So there's three things that have happened so far in this application, and you can see in the dev tools that I imported, someone else built, brought it in the application, what's happened so far. So the initial state is set. Your initial state you define in each reducer file, which you saw right here. Your default action here is going to return the state. Let me see if I can find a better one. Right here. So my initial state is set there. In this case, the initial state is an empty object. And in a lot of cases, that will be what you want. So if you're looking at this application here, my initial state, I have a counter, and I have a people array. my people object. My people object contains entities and a selected ID. Sound familiar? We saw that earlier on the slide. The next action that happened is this application is actually hitting a backend server that I have running locally. Actions are always synchronous, but an asynchronous piece of code can fire an action. So they will always happen in order, so you're never going to have to worry about race conditions. One of them will happen before the other, guaranteed. I guess that is kind of a race condition. But I receive people from the server. So you can see that my action is people from server, and my action contains a payload object. This payload object contains all of the people that I'm going to add to the store. And let's look at the code for that so that it's not totally abstract. So this is TypeScript. It's an Angular 2. But my case, people from the server, I'm returning a new object using my state and my action. Taking off the payload from the action and assigning it to my entities, taking the selected ID and assigning it. In this case, you notice I'm not modifying the selected ID because I'm pulling it from the state. In the select person case, I am modifying it via the action, and we'll see that right here. So if I select Luke Skywalker, the select person is going to fire. So that button didn't actually modify my state. All it did was fire an action that modified my state or created a new state via my reducer. So you can see if I look at my selected ID, it's now changed. That's really cool. In this example, it's a really contrived example. Some people who've used Redux, would you raise your hand again if you've used Redux? Just so that I'm not the only person talking. Raise your hand if you have a real-world example of how Redux has helped you do something. Why is Redux better? Putting you on the spot.
We have been able to actually benefit from it when updating contact settings in our application. Redux's middleware pattern allows us to abstract our interactions with the server into a single place so that if anything else fires an event or a type, we update this setting. It can be triggered and sent to the server everywhere, but also we optimistically update it through our page as well.
Okay.
So we found this just a good pattern and stuff like that.
Perfect. Anyone else?
If you have like part of your application or data that belongs in one part of your application and you maybe need to show it in multiple places, it's pretty well structured to allow you to keep it all in one place and then use that data in multiple places.
Right.
Having to sort of like worry about maybe some state getting mixed or saved.
Yeah. My favorite thing about Redux is actually very similar to that. It allows me to control the application in a way that other libraries don't necessarily manage. If I have click events happening everywhere, let's say in Angular 1, I have two-way data binding in Angular 1, which is a whole nother issue. I've got a component 5 levels deep that makes a change to that model, and now it's reflected everywhere. And I may not want that. And maybe that's only referenced locally. And so then I change the page. I just change the user object, but I have the user data cached, go to a different page, and now I'm looking at the old user object. I mean, this can solve a lot of problems. You have a single source of truth. It's not a brand new pattern. The one thing I wanted to show about this application, which is somewhat limited in the nature of the application, which is why I have the counter example, which hopefully we'll get to, is time travel debugging. Who's heard of time travel debugging? Raise of hands. All right. So time travel debugging, simply state, is that you can go backwards in time and look at what's happened through your application. So I'm going to re-render this application as if it never received any data from the store. Look at that. That was exactly what my application would look like right now if it never got data from the back end. So I can say, well, in this case, they didn't click on Luke. No one likes Luke. Just kidding. They clicked on Obi-Wan Kenobi. Now, in this case, these changes don't matter because the selected person is replacing the previous selected person. But in a counter example, let's look at that. Wrong application. And I seem to have lost it. All right, we'll go through the code. That might be just as helpful. In a counter example, we're going to have a counter, which we saw was initialized at 0, and 2 buttons. One will increment and one will decrement. If I click on increment and I click on it 5 times, I'm obviously going to have 5. I've incremented it to the number 5. If I go back in time using time travel debugging and turn one of those actions off, I now have 4. It's as if that action never took place. So because you have a flow through your application of data that Redux enables, Redux is an implementation of Flux and also not an implementation of Flux. But the Flux creator loves it, or the inventor of Flux. So that's some of the dev experiences that Redux enables. I have quite a few sources at the end of these slides. I'm sure that the slides will be available somewhere. And I can forward the link to anyone who really wants it. The Redux documentation you can find pretty easily. There's a great cartoon introduction to Redux by Lynn Clark. And there's also 2 fantastic Egghead.io lessons that are completely free by Dan Abramov, who created Redux. You can look, he's getting started with Redux. And this one in particular is great because instead of just teaching you how to use the library, he actually re-implements Redux in front of you to teach you how Redux works. And then building React apps with idiomatic Redux. This will help you connect Redux into React. And then the workshop that I started, that I'm still working on, is included at the bottom as well. I think I am out of time. Is that correct?
Yeah.
1 minute. Questions?
Can you explain why in Redux you replace state as opposed to modifying it? Why is that one of the 3 commandments?
Why? That is a great question. Let me repeat that, just so it's on the camera and I run out of time so I don't have to answer it. I'm just kidding. The question was, why are changes made with pure functions? Why can't I just modify the object directly? I have the object, it's in JavaScript, let's just modify it. There's a couple reasons for that. It's actually a fairly long discussion. The simplest explanation would be you couldn't do time travel debugging without it. There's a lot of things there's the flow that it would break if you're modifying your state constantly. And come talk to me afterwards. I'll see if I can find an article that I'll share with you. Any other questions? I'm out of time, but that's okay. Cool. All right.